Now I am outside my town this beautiful morning, and I take with me some piece of paper and try to discuss some ideas of my water stirling engine project, my crazy project. I appreciate much the comments, many good ideas and thoughts there. Well, the small pump engine you have seen before, actually we can take first thing first. The efficiency, the efficiency of all thermodynamic machine is the Carnot efficiency, and this is the basic formula, and this is temperature cold and temperature hot in Kelvin. That's the basic, and that's why I'm so curious about the first step in the engine, when you convert heat to kinetic energy, and try to do as best as possible there first. Then there will be losses, of course, in the hydraulics, and also that's obvious. I mean, you cannot compete with a classic mechanic crankshaft. It must be very efficiency, this kind of mechanics. The losses there must be completely negligible compared to the hydraulics. Well, the pump you have seen so far is some sort of fluidine variant of engine, where I have some water and a long pipe here, and these mass back and forth are the hydraulic flywheel. And then we have some check valves here, a pressure tank, here we have the output flow, and actually there should be one more check valves. I haven't used that. How actually, here is water everywhere, and maybe a tank, under pressure tank here somewhere, who actually take water from below this. So here we have an C or something. We pump up to this level and then pump it up to this. So if we look at the pressure volume diagram, this part suck from below, and this part pump above. This setup could be perfectly fine, maybe if the main goal is just to produce pumped water. But the obstacle is obvious that, and that's great that some of you comment that, if you increase this volume and temperature here, I mean the power, pressure and volume on these axles, when you increase the hot side here, you increase the area, and that will increase the power output exponential to the temperature rise. So if I drive this large engine I have shown you with this kind of setup, and around, let's say, 1 hertz, maybe I don't come up to 1 hertz, maybe I drive it 0.3 hertz or so. But anyway, this pipe must be very large. I mean, it must be about 1 to 2 cubic meter. Otherwise you get a lot of turbulence. You know, in the pipe, you can either have, if you have a small pipe with very high speed, then you get turbulence instead of just laminar flow, and then you ruin all the efficiency. So if I pump up this power to around kilowatt level, then this will be enormous amount of water. You can of course made a spiral. Sorry for a spiral tank. So you put it together here on one place instead of a long pipe, of course. But anyway, it will be a lot of water and a large structure for that. So my idea is actually to replace all this stuff with one single device. And here maybe you can help me with advice. So I will have it will be something like this. I have my water level, and here I will have some sort of pump or turbine. Let's see here. We're turning around, and maybe it will be here. We will have one axis and a propeller and a similar spiral shell. So this turbine go just like this, back and forth. And here I could, on this axis, I could put an electric motor generator I can control by electronics. When I was young, I was work on power plants, and I was close to many of these Kaplan turbine in hydropower. Of course, my turbine will never ever come close to the efficiency of a big, large Kaplan turbine, because they have a lot of moving parts in the and very much optimized, and it used on only one pressure. I mean, this kind of turbine must handle the whole range of pressure from the PV, all the way from 0 in pressure to the peak pressure. And then that's maybe a completely difficult task to do some sort of classic turbine. Anyway, I don't care so much about the efficiency here for the first step. I'm most curious about this first step, to convert the heat to this PV diagram, and I will measure the pressure and the volume change. And if I have 25% efficiency of these hydraulics, I don't care so much in the first step. If you have some ideas, I welcome it. There may be several options of pumps or rotary system for maybe a better solution. I hope you enjoy to follow my crazy ideas. I don't know where this journey will end, but it's a kind of art. Have a nice day.